Hello everyone. In this video we look at SSL man-in-the-middle attack over wireless. So before we begin with the actual attack, let's try and understand what a man-in-the-middle attack actually means. So basically, man-in-the-middle is an attack in which the hacker places himself in between the communication of his victim and another host. And basically all the traffic which is sent between the victim as well as the host it is communicating with is absolutely free for the hacker to look into, tamper, modify and then relay back on either side. So because of the nature of the attack, it is commonsensical to assume that it has to be done at layer 2 so that the hacker has total control over which packets are going through and which packets are going out in either direction of the communication. So with this basic background in place, let's move forward and look at tools of the trade. So because this is going to be a wireless man-in-the-middle attack, we need a wireless card, and it is preferable to have a card which has Atheros chipset. Simple reason being that Atheros chipset is actually very well supported in the open source community, and the MAD Wi-Fi NG drivers which are available actually work quite well in setting up the card into AP mode or promiscuous mode and any other such modes which one would desire. Also, we would require the DNS spoof utility. You can check out how to get this utility in the link section on this page. And the delegated proxy server. So delegated actually has proxying ability for many protocols, but in this specific example we'll use its SSL man-in-the-middle proxying capabilities. So now let's move forward and look at the attack premise. So the typical attack scenario for a wireless man-in-the-middle attack would be where we would have a victim laptop which is actually searching for a wireless network. So let us assume, for sake of simplicity, that is an open network called default. Now there is also going to be a hacker present in the vicinity. Now I've actually drawn the hacker more of from a module perspective, that the hacker consists of two distinct modules. One is the DNS spoof and the other is the delegated. Now the hacker is also going to set up a honeypot which is actually going to be in an access point mode and which is going to make the victim connect to it. So because the victim is searching for a default SSID, this honeypot is going to be set up with a default SSID. So basically what happens is the hacker brings up his honeypot with the same SSID that the victim is searching for, and because of that the victim actually connects to the hacker honeypot. Once this happens, the hacker actually gives the victim an IP address over DHCP, and a layer 2 communication is actually possible between both of them over IP. Now on the other end, because the hacker has to do a man-in-the-middle attack using some server on the internet, he has to be himself connected to the internet. Now this connection between the hacker and an internet can be in two ways. One possibility that it is over Ethernet, or another possibility is that the hacker has two client wireless cards, one which is in AP mode which is actually connected to the victim, and the other which is in a client mode and connected to the internet using some other access point or provider. So this is what the attack premise and background actually is going to be, and now we will look at how using this setup it is possible to do an SSL man-in-the-middle attack. So in this presentation basically we'll look at the logistics and how the flow of packets is going to be. In the next video we'll actually look at a practical example in which this attack is carried out. So what are the attack steps? Now for the sake of simplicity, let us assume that the hacker laptop has an IP address of 1.1 and the victim is given an IP address of 1.2. Now basically an IP layer connectivity has been established between both of them, and as soon as this happens, let's say the victim actually types in mail.yahoo.com in his browser URL. As soon as he does that, a DNS request will be generated from the victim for mail.yahoo.com. Now this request actually arrives to our DNS spoof utility, which will actually be configured to reply to this DNS request, and it replies back to the victim saying that the IP address for mail.yahoo.com is nothing but 192.168.1.1, which is the hacker's laptop's IP address. So what DNS spoof actually is doing is that for any DNS request generated by the victim, it is going to reply back with the IP address of the hacker laptop. So what does this ensure? Now when victim wants to communicate with mail.yahoo.com, the IP address it will use basically in the transport layer is going to be 192.168.1.1, which means that the victim will basically send packets destined for mail.yahoo.com to the hacker laptop's network stack, which is bound to 192.168.1.1. Okay, so now moving ahead, once the DNS reply is received, now the victim would actually make an HTTPS request to try and connect to mail.yahoo.com. Now, because in the DNS spoofing part, the IP address of mail.yahoo.com has been set to 1.1, this HTTPS request is now destined to port 80 of the hacker's laptop, right? And this is where our delegate D proxy server daemon is actually running. So now what the proxy server daemon does is that it is going to send back a false certificate to the victim pretending to be mail.yahoo.com. Now this is when generally you receive that alert on your screen saying invalid certificate from website, and statistics actually suggest that almost 95% users accept the false certificate alert pop-up. So when this happens, the victim's browser actually accepts the certificate and uses it for encryption. After that, the browser will actually send all the authentication data, which would be the username and the password which the victim has entered in the login screen, to delegate D. Now delegate D in turn, what it does is that it is actually going to send this data over the internet to yahoo.com, and then basically whatever data Yahoo sends back, it is going to send back to the victim. And all this happens transparently as delegate D is a proxy server. So in this entire flow, as we are observing, that once the certificate error pops up and the client accepts it, the client browser is actually going to happily send all that authentication data, username, passwords and everything to delegate D, which in turn will forward it to Yahoo on the internet, and when the replies from Yahoo come in, it's going to forward it back to the victim. So if you notice, delegate D, which is totally controlled by the hacker, is the real man in the middle utility, which is actually proxying all the traffic on both sides and at the very same time peering into what data is going by. So let's actually look slightly more deeper into how delegate D functions. So in the previous example, we've seen that the victim sends all his packets to delegate D, and delegate D in turn sends them to Yahoo, and when Yahoo replies back, it forwards them back to the victim. So now from an SSL perspective, what does this mean? It actually means that all communication between the victim and delegate D happens using a spoofed certificate which was generated by delegate D and sent to the victim. And all communication between delegate D and Yahoo happens using Yahoo's certificate. So if you notice, for any packet the victim sends, the victim encrypts it using the public key specified in the spoofed certificate. Delegate D decrypts that, takes that data, encrypts it using Yahoo certificate, and then sends it back to Yahoo. Yahoo decrypts it using the certificate, sends it back to delegate D, which once again encrypts it and sends the reply back to the victim. So delegate D is actually the real man in the middle utility, which is sitting in between, encrypting and decrypting on both sides, taking the data from the victim, forwarding it to Yahoo and sending it back to the victim. So that is why the SSL man in the middle attack is actually possible, and it happens very transparently. Well, this is all about the setup. Now from a demonstration perspective, we will try to recreate this entire setup. Now the video which we will shoot, unfortunately, because there are two entities involved, one is the hacker laptop and other is the victim, we will concentrate more from a victim's perspective. So the setup will actually be made and the victim will connect to the setup, and we will see what is the overall experience from the victim's perspective. Because I have discussed all the basics of setting it up, right from downloading of DNS spoof to delegate D, it is left as an exercise to the user to make the actual hacker setup. If you face any problems in doing that, feel free to send me an email and I will guide you through it. Well, that's all for this video. In the next video, we'll look at the demonstration. Thank you.